So let's start talking about addition, subtraction, and number bonds as we go uh, above 10. So here's a problem. Here's a simple problem. We want to add. So let's first count. How many do we have on the left hand side? We have 1, 2, 3, 4, 5, 6, 7 red squares on the left, and 1, 2, 3, 4, 5 red squares on the right. So we want to figure out what is 7 plus 5 equal to. Well, the way that we would like you to think about this problem is that we really want to uh, make tens and then try to figure out what's going to happen. So now, first of all, there are going to be two number bonds that are going to be associated with it. First, we want to make a 10, right? That's important because so let's try to make a number bond which is going to be a 10. So I have so remember, I want to make a 10 and I have a 7 over here. So how many more do I need to move? Well, clearly I will need to put in 3 to make a 10. That hopefully we can do at this stage. But if you want to be reminded, then you can just move. So please remind yourselves, your child, that this is the 7 that we had initially. And now what I'm going to do is I'm going to move 1, 2, and 3 over here. So now you can count. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are going to be 10 red squares on the in the rectangle. So we have a box of 10 and then we have 2 spare. So that means the answer is going to be 12 because it's 10 and 2 which make it 12, and this 1 is a reminder that this is a box of 10 and the 2's are these 2's right over here are reflected in the 2 right over here. And also what we have done is we've broken up a 5. So we had a 5 that we broke up into we moved 3 blocks into the big red rectangle, and then the remaining 2 blocks were left over here. So this was also a number bond. So right now we don't want to count on. We will count on, but at this stage we want to remind ourselves that we are using number bonds to add. So while there will be a strategy in which they will eventually start to count on and they will eventually learn the addition tables, but at this stage we really want them to use their skills of building up a number by using number bonds. From 7 they go to 10, and then they have a number bond which is 5 is comprised of a 3 and a 2, and hence the answer is 12. It may seem a bit more convoluted, but sort of getting them to think about building and breaking up numbers, which is again an important skill that we are trying to teach them at this stage. So now we have another problem that we have, as you can see, 12 blue rectangles right over here. And I can write down so here are the 12 blue rectangles, and I want to add 4 more into it. So I want to figure out what is 12 plus 4. Well, the way we want to think about it is that we already have a box of 10 right over here. So this is a box of 10 blue rectangles, blue triangles. And now we have 2 extra, and this again I'm reminding you this one is a representative of this 10, and the 2 over here are represented in the ones place. Okay, so now we have 12 and we want to add 4. So now what we can do is, so as the child should be able to see that we are really, what we're doing is we've broken up a 12. So this is what we've really done. We've broken up a 12. So we've broken up a 12 into a 2 and a 10. And now in this 2, what we can do is we can add the 4. So we're really doing 2. We're going to add the 4 into it. So what we're going to do is we're going to add the 4 into the 2, and this number is going to be a 6, and this 10 stays as a 10, so this will form a 16. Okay, so this is how we can add 12 plus 4 to 16. Okay, now let's try some problems with subtraction. So here's so again I have 14 white balls, and let's say what I want to do is I want to subtract. So let's start doing the first problem. I want to do 14 minus 2. Okay, so again I have a box of 10. So right here is a box of 10 balls, and then I'm going to subtract off 2 balls from here. So again, what we're trying to remind you is that you're trying to remind the child that here's a 14. I've broken up the 14 into a 4 and a 10, and we're going to subtract off the 2 because we can. If you have 4 balls here, we can certainly subtract off the 2, and we're going to be left with 2 balls over here, and the 10 stays as is, and we're going to have 12 balls. And the way we want to show it is that we can actually remove the 2 balls from here, and these balls are gone, so we're going to be left with a total of 10 plus 2, 12 balls. That's one thing that we can do. Okay, but now we can have another problem. So let's go back to 14. So here's 14 back again, and now we have a problem. So this answer was equal to so this answer was equal to 12. And now what we can do is let's try to look at a new problem, like maybe we want to figure out what is 14 minus 6 equal to. But now we again have a 10 and 4, but now we can't, if we have 4 chocolates, we can't really eat the 6 chocolates from there. That's not possible. So what we really have to do is that we have to break up the, so what we have to do is we have to work harder. So now we have, what we're going to do is we're going to have a 14. So again, we're going to have a 14 right over here, and the 14 will again get broken up into a 4 and a 10. But since we can try to subtract 6 from 4, but that we can't do because if you have 4 chocolates, you can't eat more than what you have. So we are going to subtract the 6 from the 10, and we're going to get 4 over here, and we still have the 4 right over here, and now the 4 and the 4 will give us back an 8. And the way we think about it is actually that we are crossing off these 6 of these, and now we're going to be left with 8 white circles, 4 from the 10 and 4 from the ones place. Okay, so this is how we can subtract. So now we go on to some other really cool things that we learned earlier, but we still want to remind ourselves of what we know. So let's see, for example, if we have a problem like, let's say we know what 5 plus 4 is, and that we know is equal to 9, and we can do it in various ways. But now the question is, if 5 plus 4 is 9, what is 15 plus 4? So now please note that you can do it in 2 ways. You have number bonds that you can use. So for example, the answer is going to be 19. So there are 2 ways that you want to remind yourselves, your child, of this idea that here's a 15. So here's a 15, and the 15 gets broken up into a 10 and a 5. And if we add a 4 over here, we get a 9, and the 10 stays as a 10, and the answer is going to be 19 when you think about number bonds. That's one way to think about it. The second thing is that if 5 plus 4 is 9, so we already know that 5 plus 4 is 9, then please note that this is just 5 plus 4 is 9. There was an extra 10 and the 10 stayed on, and this is exactly what we discussed earlier when we were adding, that when the augend, please remember this is called the augend, so this is the augend. So when the augend increases by 10, the sum is going to increase by a 10 also. It's going to be the same number. So that's the same principle, that when the augend increases by any number, the sum increases by the same number. And now also please note that by the commutative law that we've already talked about, this also has to be true that 4 plus 15 also has to be equal to 19. We don't have to repeat the calculation. It's just putting things together, so you can have things on the right or the left. It doesn't matter. The total number of things has to stay the same. That was the commutative law. Okay, and now on a very similar note, we can also do the same thing with subtraction, that if, let's say, 8 minus 3 is equal to 5, then 18 minus 3 must be equal to 15. And please note that, we can again use number bonds as we did on the in terms of addition. We can also remind our child that this is the same principle, that if you have if the minuend, so remember this is the first term is called the minuend, the second term is called the subtrahend. So if the minuend increases by 10, the difference increases by 10. So this went up by 10, which means that the difference must also increase by a 10. A different way of doing the same thing is by using number bonds, and you can show that really if you have 18, so you have an 18, the 18 gets broken up into an 8 and a 10, and when you subtract off 3, going to be 8 minus 3, that's 5. Nothing happens to the 10, it stays put. So then this is going to be a 15. That's explaining the same idea, but doing it in a different way with number bonds. Okay, so that's another interesting fact that you can discuss with your child. And using the same ideas, we can also talk about things like these number patterns that we saw earlier, that if, for example, if 10 minus 6 is equal to 4, then it must be true that 11 minus 6 must be equal to 5, because the minuend has increased by 1, so the difference has to increase by 1, and 12 minus 6 must be equal to 6, because we are increasing the initial number of chocolates by 1, and if you eat the same number of chocolates, then what remains must also increase by 1. And the same idea applies to addition when you go across the boundaries, that if 7 plus 5 is equal to 12, then 8 plus 5 is equal to 13, and 9 plus 5 must be equal to 14, because again, if you add the same number of chocolates, but each time you start out with one more chocolate, then you must end up with one more chocolate. So you don't have to recalculate, and you should be able to see these number patterns emerge as you add or subtract.